Welcome back to the deep dive. Today, we are going to do something that might feel a little uncomfortable. We are going to take a metaphor that you likely use, I don't know, 20 times a day, maybe, without even realizing it, and we're going to completely dismantle it.
I know exactly which one you mean.
I'm talking about the cloud.
And I don't think this is an exaggeration. Arguably the most successful piece of marketing in the history of technology.
It's brilliant, really.
It's absolutely brilliant.
Because think about the imagery that comes to mind when you say, oh, I'll just save that to the cloud. It's white, it's fluffy,
Yeah.
it's floating somewhere up there in the stratosphere. It's clean, it's silent, and I think most importantly, it's weightless.
Weightless. That's the key.
It suggests that our digital lives have somehow ascended to this magical, ethereal heaven where nothing ever breaks and nothing ever gets dirty.
Which is a beautiful image, but it has a very specific function. It's designed to hide the reality.
Hide it how?
Well, the metaphor implies that data is immaterial, that it doesn't take up space, that it doesn't consume energy, and that it sits outside the laws of physics.
Right.
It suggests that once something is digital, it's, immortal. It's untouched by the grime and the mess of the real world.
And today, we are going to crash land that cloud. We're going to drag it out of the sky and pull it through the mud, the sand, the dust, and quite literally the swamps of Louisiana. Because we are diving into a massive piece of new scholarship, the Sage Handbook of Data and Society, which just came out in 2025.
And this isn't just a tech book you'd grab at the airport. This is a really significant academic collection. It marks a definitive shift in how we understand the internet and, our relationship to it.
Right, because the editors and authors here are arguing something that sounds, well, totally counterintuitive. They're saying data is heavy.
It's heavy.
It is fragile. It is deeply, inextricably human. And it is constantly on the verge of, rotting away.
It's a stark contrast to what we've been told for the last 30 years, isn't it?
Yeah.
It really challenges the fundamental assumptions we have about the digital age.
Let's talk about that shift in mood, because the introduction to the handbook makes a really big deal about this. For a long time, we were living in the era of, the California ideology.
A bright and breezy era. That's what they call it.
Exactly. The era of Moore's Law. The idea that processing power doubles every 2 years, the cost halves, and therefore, inevitably, society just gets better and freer and more democratic on that same schedule.
Yeah, it was this determinist optimism. The internet was going to be the solution to everything.
We believed it. We thought if we just connected everyone, democracy would flourish, economies would boom, and information would be free for all.
But the source material argues we are now in the era of cracks in digital optimism. Just look at the last decade. You don't have to look far. We've lived through the Cambridge Analytica scandals, the weaponization of data for political micro-targeting, the implosion of the crypto markets, which just wiped out people's life savings.
And now the existential anxiety around deep learning and AI.
Right. It's constant.
It really feels like the realization that more doesn't necessarily rhyme with better anymore.
That's a great way to put it.
Just because we have more connection doesn't mean we have more understanding. In fact, I think sometimes it feels like we have less.
Precisely.
Yeah.
So to understand where we are now, the authors in this handbook argue we have to stop looking at the screens.
Okay.
We have to stop looking at the content, the tweets, the videos, the memes. We need to look at the plumbing. We need to look at the materiality of data.
This is what they're calling critical data studies. It's not about the code.
No.
It's about the infrastructure that keeps the digital world from collapsing back into dirt. So our mission today is to explore that materiality. We're going to look at the cables, the sand, yes, actual sand, and the maintenance workers, who are essentially the only thing standing between us and a total digital blackout.
And to do that, we have to start with a concept the authors call the material turn.
Okay, help me out here. In academia, they love their turns. We have the cultural turn, now the material turn. Is this just jargon, or does it actually change how I should see my phone?
Oh, it changes everything. See, for a long time, if you studied media or the internet, you were studying the cultural turn.
Right.
You were obsessed with symbols, with language, representation. What does this meme mean?
Yeah, how does this online community define itself through text? How does this profile picture represent identity? All that stuff.
Exactly, which is all valid. But the material turn kind of grabs you by the shoulders and says, wait a minute, none of those symbols exist without physics. It shifts the focus from sociology to biology to geology to infrastructure. The core insight is that digital media isn't magic. It relies entirely on the physical environment. It relies on the Earth.
And you don't mean the earth in a kind of hippie Gaia sense. You mean literal dirt.
Literal dirt and sand. Actually, let's start with sand, because one of the most eye-opening case studies in this entire handbook comes from Ben Mendelsohn's research on Eco-Atlantic City in Nigeria.
I looked up photos of this place while I was reading the notes. It's wild.
It is.
Can you describe Eco-Atlantic for the listener who hasn't seen it?
Okay, so it's often dubbed the Dubai of Africa.
Yeah.
It is this massive, gleaming, coastal mega development in Lagos.
And Lagos is a megacity. It's crowded. It has massive infrastructure challenges, traffic, power outages.
Huge challenges. So the developers decided, rather than trying to fix the existing city, they would essentially build a new one from scratch.
Right.
But here's the kicker. They aren't just building it on empty land. They are reclaiming land from the ocean.
Reclaiming is such a polite word for what is actually happening, isn't it?
It's a total euphemism.
It sounds like they found some lost land and just brought it back.
Not at all. They're building a city where there used to be water. And to do that, you need mass. You need matter.
You need stuff.
You need a lot of stuff. So the process involves these massive dredging ships. They're essentially industrial vacuums on the water, sucking up millions of tons of sand from the continental shelf, from the ocean floor, and pumping it onto the coast to create a new peninsula.
So we're talking about moving mountains of earth from the bottom of the sea to the surface. It's geoengineering on a massive scale.
It's exactly that. And Mendelsohn argues that in this context, sand is a sedimentary medium.
Okay, hold on. A sedimentary medium.
Yeah.
We usually think of a medium as TV, radio, or the internet. That's a bit of a brain bender. How is a pile of wet sand a media technology?
Think about the purpose of the city. Eco-Atlantic is being built specifically to support global finance and data.
Yeah.
It's designed to be a high-tech hub. It's got its own independent power grid, its own fiber optic connections, its own security. They are physically separating land from water to create a value-generating space.
They're building a fortress.
A fortress for data, yeah. Insulated from the chaotic reality of the rest of Lagos.
So the cloud, in this case, all the high-frequency trading, the digital banking, is actually resting on a foundation of dredged ocean floor.
Yes.
It physically cannot exist without that displaced sand.
It can't. And the visual connection that Mendelsohn draws in the chapter is so stark. On one side, you have the gleaming computer renders of the future city. You know, glass towers, clean streets, people in suits holding tablets. That's the digital image.
The marketing.
The marketing. And on the other side, you have the gritty industrial reality of the dredging ships spewing black sand and water to make that image possible.
It completely grounds the technology. It implies that every gigabyte of data stored there has a corresponding weight in sand. It reminds me of the other case study in that same chapter, which takes us from the ocean floor to the highest mountains on Earth.
Right.
This is Aisha Omer's research on the fiber optics of the Himalayas.
This is the story of the China-Pakistan Economic Corridor, or CPEC. It's a massive infrastructure project connecting China to the Arabian Sea, running right through Pakistan.
And a critical part of this is a fiber optic network.
A huge one.
Yeah.
Running through the Karakoram Mountains.
Now, I've seen documentaries about the Karakoram Highway. This is not a gentle landscape. This is rugged, high altitude, and prone to massive landslides.
Oh, yeah.
It does not look like an easy place to run a delicate glass cable.
It's incredibly hostile terrain for any kind of infrastructure. But the state narrative from both China and Pakistan is one of a digital revolution.
Of course.
They market this cable as the bringer of connectivity, modernity, economic freedom to these remote borderlands. It's the information superhighway. They sell it as this frictionless path to the future.
That's the brochure. That's the ribbon-cutting ceremony speech. But what is the reality for the people living in those mountains?
Well, the locals have a very different phrase for it.
Well,
They see a future of dust and smoke.
dust and smoke. That sounds almost biblical. It sounds like an apocalypse, not a tech upgrade.
It's very literal for them. You have to understand, constructing a digital highway through fragile mountains isn't about typing code. It involves blasting, digging, heavy machinery, diesel fumes.
And creates ecological ruin.
Total ruin.
Yeah.
It destabilizes the slopes, which lead to more landslides.
So the dust isn't just dirty, it's a signal of danger.
Exactly. Omer argues that dust becomes a medium in itself.
Just like the sand.
Just like the sand, it represents the ecological cost that accompanies the construction of connectivity. So while the data might flow smoothly through the glass cable inside the tube, The reality outside the cable is gritty, dusty, and unstable.
It's the friction between the digital promise and the physical toll. And the text mentions that this dust induces anxiety in the locals. It signals the destruction of their indigenous lands. So when we talk about the materiality of data, we aren't just talking about servers in a data center. We're talking about the dust in the lungs of the people living next to the fiber optic cables.
And this brings up a really, really important critique mentioned in the source material regarding how we view the global south.
Right, because usually when Western media talks about tech in places like Africa or South Asia, it's almost exclusively about e-waste.
Yes.
We've all seen the photos of kids in Ghana burning computer wires to harvest the copper. It's a tragedy, but it's a very specific narrative.
And that is a real and tragic part of the story, absolutely. But the expert perspective in this handbook is that we need to stop seeing these regions only as sites of objection or dumping. These case studies, Lagos and the Himalayas, they show that these regions are active sites of extraction and construction.
So they aren't just where the tech goes to die, it's where the tech is born.
Precisely. They are dredging the sand and blasting the mountains to lay the cables that connect the whole world. They are central engines of the material infrastructure.
So without the geography and labor of the global south, the cloud in the global north just collapses.
It collapses. It doesn't exist.
That is a crucial reframing. It gives agency back to these regions, even if the work is dangerous. It reminds us that the internet isn't just floating over these places, it is being dug out of them.
And that brings us to the next logical step. Because once you've dredged the sand, built the land, and blasted the tunnel to lay the cable, the job isn't done.
No.
In fact, the hardest part is just starting. You have to keep it working.
Which leads us to section 2 of our deep dive. Infrastructure as a verb.
This is one of my favorite concepts in the book because it's so simple, but it changes how you look at the world.
Okay.
We tend to think of infrastructure as a noun. A bridge is a thing. A server is a thing. A cable is a thing. It's static. It just sits there.
Right. We talk about it as an object, the road, the grid, something that has been placed in the world.
But the authors argue that infrastructure is a verb. It is a practice. It is something you do. Data infrastructures do not exist without maintenance.
There's a great line in the notes. Behind every successful system stands a mechanic with a wrench.
Or a data manager with a spreadsheet. It's the visibility paradox, right? We only notice infrastructure when it breaks.
Oh, completely.
When the Wi-Fi goes down, suddenly the router is the most important object in the house.
Yeah.
You stare at it, you hate it.
You unplug it, you plug it back in.
But when it works, it's invisible. Maintenance is the invisible labor that prevents that breakdown.
Right.
It's the constant, frantic paddling of the duck underneath the water that makes the gliding look so smooth.
To illustrate just how frantic that paddling can be, the handbook takes us to a place that knows a thing or two about breakdown. Louisiana. Specifically the aftermath of Hurricane Ida in 2021.
This case study by Stephen J. Jackson and his colleagues is just incredibly vivid. Hurricane Ida hits with 150-mile-per-hour winds. It snaps utility poles like toothpicks. The grid is decimated.
And in the modern world, when the power goes out, the data goes out.
They're the same thing now.
You have no internet, no cell service. You are completely cut off.
Right. And here's the complication. This is South Louisiana. The terrain is described as terraqueous.
Terraqueous. I had to look that up. It means land and water mixed together.
Yeah, it's not quite solid, not quite liquid.
It's swamp.
It's swamp. It's wetland. It's eroding coast. So you have utility poles down in the muck. Now, put yourself in the shoes of a homeowner there. Your roof is gone. You need to file an insurance claim. You need to apply for FEMA aid. How do you do that in 2021?
You have to upload a photo to a website. You have to submit a digital form. You can't just mail a letter anymore. The bureaucracy is digital.
Exactly. You need data. But here is the profound irony. You cannot upload your insurance claim photo to the FEMA cloud if the physical wooden pole in the swamp isn't fixed by a human being.
And fixing a pole in a swamp is not like fixing a pole on a suburban street. You can't just drive a truck up to it.
No. The source describes this choreographed dance of repair. It's a whole sequence. First, you have to clear the debris. Then you have to install the pole. Then the electrical lines. Then the telecom lines.
And in the swamp.
In the swamp, they have to use what they call a kludge, a workaround.
A kludge is engineer speak for a messy solution that works, right? Like duct taping a bumper on a car.
Yes, but on an industrial scale. In this case, the kludge involves workers using airboats. They are wading through chest-high muck, fighting mosquitoes, the humidity, the heat, physically planting these poles into land that is slowly disappearing into the ocean.
That image is just so powerful. We think of FEMA aid as a digital transaction. I submitted my form. It feels instant. But that transaction is physically supported by a guy in chest-high mud wrestling a utility pole.
That is the sweat behind your data.
Right.
And there is a climate angle here, too, that we can't ignore.
Right.
Maintaining data requires, as they put it, holding on to an increasingly unstable ground. As climate change erodes the coast, the physical footprint of the internet, the poles, the cables, is literally sinking.
So maintenance isn't just about fixing what broke in the past. It's about fighting a losing battle against the environment in the future.
Yes, a constant battle.
It really makes you appreciate the fragility of it all. We assume the internet is permanent, but in places like Louisiana, it's holding on by its fingernails. Speaking of fragility, let's look at a completely different kind of maintenance. We're going from the swamps of Louisiana to a sterile room in Canberra, Australia.
The Australian National Soil Archive.
Right.
This is a fantastic example because it moves us from fixing things to maintaining knowledge. This archive holds 70,000 soil samples, some of them dating back to 1924.
1924, that's soil from before the atomic bomb testing, before industrial agriculture took over. I mean, that is a biological time capsule.
It is invaluable scientific data. It tells us the history of the continent's chemistry. But physically,
It's dirt in jars.
it's dirt and jars. That's all it is.
So what does maintenance look like here? It's not wading through swamps.
No, it's much more subtle. It's these strictly controlled environments. They have to control the humidity and the temperature to prevent mold or degradation. But more importantly, they have to maintain the metadata,
The label on the jar.
the label, the database record that says where it came from, how deep it was dug, when it was collected, all of that. And the authors propose a thought experiment called the Vandal.
Oh, I love this part. It's like a horror movie for librarians.
It really is.
Oh,
Okay, so imagine a vandal breaks into the archive at night. They don't steal anything. They don't smash the jars. They simply open every single jar and dump the soil onto the floor. They mix it all up into a big pile.
and then they just leave.
They leave. So when the scientists come in the next morning, what do they find?
They find a mess. They find a pile of dirt.
Exactly. In seconds, that material transformed from scientific data back into just dirt.
That is, wow, that's the aha moment right there. The substance didn't change at all, but its value completely vanished.
The soil didn't change chemically. The atoms are the same, but the infrastructure, the container, the label, the separation was destroyed.
Yeah.
The takeaway is that data is only data because of the maintenance of its container. Without the infrastructure, data is just a mess on the floor. It loses all meaning.
The source material uses this phrase that I thought was so poignant. It says, data are weak, poor, fragile. We think of data as this powerful, immortal thing, but it's actually incredibly weak. It needs a safe house to survive.
It needs a house and it needs a caretaker. Whether that's a scientist checking humidity levels or a line worker fixing a pole, data cannot survive on its own.
Yeah.
It constantly wants to return to entropy. It wants to go back to being dirt.
So we've talked about physical mud and physical soil, but there's another kind of maintenance that is even more complex and frankly more disturbing.
Yeah.
The maintenance of human identity.
This brings us to section 3. When maintenance fails, the human cost. And this is where the stakes get incredibly high. We are moving from the maintenance of things to the bureaucratic maintenance of people.
We're looking at a case study on Aadhaar in India.
Aadhaar is the world's largest biometric ID system. It's a national database that aims to give a unique digital identity to every resident of India. We're talking over 1 billion people, based on their fingerprints and their iris scans.
The idea being you prove who you are with your body, not just a paper card. It's supposed to be fraud-proof. It's supposed to be the ultimate modern convenience.
In theory, yes. But the system relies on a maintenance task called entity resolution. This is the constant work of ensuring the data record matches the real human being.
And Ranjit Singh's research highlights what happens when there is a glitch in this maintenance.
It's a glitch.
And a glitch here doesn't mean you can't load a web page. It means you don't eat.
Correct. There's a story about a fair price shop, a government ration shop, in a hilly village in Rajasthan. To get their food rations, villagers have to scan their fingerprints on a point-of-sale machine.
Like a credit card terminal at a grocery store.
Exactly like that.
Yeah.
But that machine requires an internet connection to verify the data against the central server. And in this hilly village, the signal is terrible. It cuts in and out. The topography, the hills, they block the cloud.
I think I see where this is going. This is not going to be good.
The shop owner has to hike up a hill to catch a signal. And he isn't just hiking alone. The villagers follow him.
Wait. So you have a procession of people, maybe carrying their ration cards, hiking up a mountain just to get the machine to beep so they can buy rice?
That's exactly what happens. And here's the exclusion. Who cannot climb a hill?
The elderly, the disabled, the sick, the people with mobility issues.
The very people who need the rations the most, they get no food because they cannot physically participate in the maintenance of the connection. The infrastructure demands a physical feat they cannot perform.
And there's another layer to this failure too, right?
Yep.
The source calls it fading features. This one really stuck with me because it feels like the body itself is rejecting the system.
This is just heartbreaking. The system relies on fingerprints. But many of the people using this system are manual laborers.
Okay.
They work with stone, with bricks, with chemicals, with rough materials. Over years of hard labor, their fingerprints literally wear down. They fade, they become smooth.
So the machine rejects them.
The machine says, no match found. The data model assumes a standard, clear fingerprint. It does not account for the worn hands of a laborer.
That is a profound failure. The person is standing right there. They are flesh and blood, you can see them. But because their body doesn't fit the data model, they effectively disappear from the system.
The authors call this residual categories. If you don't fit the model, you fall into the residue. You are invisible. And to survive, you have to engage in what they call maintenance of the self.
Maintenance of the self, what does that mean?
It means you have to work to maintain your own data body. You have to climb the hill. You have to try to heal your hands, maybe use lotion for weeks just to get a scan. You have to constantly prove you exist to a machine that is skeptical of your reality.
It really flips the script. We usually think technology serves us. Hey, Siri, do this. But in this case, the human is serving the technology, hiking up mountains and altering their bodies just to be recognized.
It connects right back to that idea of data being fragile. Your identity in the database is fragile. If you don't maintain it, if you don't align perfectly with the sensors, you cease to be a citizen in the eyes of the state infrastructure.
This issue of the model not matching reality brings us to another fascinating example in the handbook, artificial intelligence and the housing market.
Yes, this is Samir Passie's research on AI maintenance. We often hear about AI learning. We treat it like a child getting smarter, but we don't hear much about AI forgetting or drifting.
The example here is Zillow, the real estate site. A few years ago, they had this feature called the Zestimate, which used an algorithm to predict how much a house was worth.
And they went all in.
They started buying houses based on these predictions. They bet the company on it. This was their Zillow Offers program.
Right. They trusted the model implicitly. They thought they had solved the housing market with math. But then COVID-19 happened.
And the world changed overnight. People stopped moving or they moved to different places. Prices went crazy. The suburbs exploded.
The housing market behaved in ways that were historically unprecedented. The patterns of the past, which the AI was trained on, no longer applied to the present. This is what they call data drift.
The world drifted away from the model.
Exactly. The model kept making predictions based on 2019 logic in a 2020 world. It was looking at a map that no longer matched the territory.
And the result was bad predictions.
Terrible predictions. Zillow bought houses for too much money, couldn't sell them, and it led to massive losses, and eventually they had to shut down that whole division and lay off thousands of people.
So the AI didn't break in the sense that the code stopped running. The screen didn't go black. It broke because it stopped understanding reality.
And this highlights a crucial form of maintenance called telemetry.
Telemetry. That sounds like rocket science.
It's the dashboard of the car. It's the gauges. Practitioners have to constantly monitor the model to see if it's drifting. They have to engage in what the text calls broken world thinking.
Broken world thinking. What does that mean?
It means assuming the AI will fail. Instead of assuming it's perfect, you assume it's going to break, and you build systems to catch it.
You anticipate the failure.
It's a form of maintenance that is purely about anticipation. You have to wake up every morning and ask, how will the world change today that will confuse my algorithm?
It sounds exhausting. It sounds like parenting a toddler, where you have to baby-proof the room every single day because they learn a new way to hurt themselves.
It is exhausting. It's constant vigilance. Because if you stop watching, the model drifts, and suddenly you're losing millions of dollars, or in the case of something like healthcare or policing AI, you could be ruining people's lives.
So we've gone from the micro level, the fingerprint, the soil sample, the single utility pole, to these massive systems. But how do we wrap our heads around the whole thing, the entire beast?
This brings us to Section 4, scaling up.
The challenge here, according to the source material, is that we have great stories about the micro, like the pole in the swamp, but it's hard to map the macro.
Right. We tend to focus on platform studies. We study Facebook or Google or Amazon as if they are these monolithic kingdoms. We look at the app. But Chapter 3 by Lai and Frensberg argues that we need to look at the plumbing underneath these platforms to really understand power.
They introduced a tool called the Digital Communications System Matrix, or DCS matrix.
It sounds technical, but it's actually a really helpful mental model. Think of it like a layer cake of the internet.
Okay, I'm picturing a cake. What's the bottom layer?
Layer 1 is access networks. This is the last mile. This is the wire coming into your house. It's Verizon, AT&T, or your mobile carrier.
The utility bill I pay every month. The guys who come out in the van.
Exactly. It's heavily regulated, usually national. We know who these players are, they're utilities.
Okay, what's the next layer up?
Layer 2 is backbone networks. This is the hidden plumbing. The submarine cables we talked about earlier, the massive data centers in the desert, internet exchange points where different networks shake hands and pass traffic.
This is the stuff that's usually hidden inside the cloud metaphor.
Yes. It is less transparent and highly speculative. This is where the heavy lifting happens. This is the global highway system.
Layer 3.
Applications. This is the interface. The operating systems, iOS, Android, the app stores, the browsers. This is where we, the users, live. This is what we think the internet is.
And the top layer, the frosting on the cake.
Data, but specifically the invisible data layer. Third-party cookies, software developer kits or SDKs, the tracking infrastructure that follows you across all the other layers.
So why do we need this matrix? Why does breaking it down like this matter?
Because it allows us to track infrastructural power. And here's where it gets really interesting and honestly a little scary. We are seeing a trend called vertical integration.
Vertical integration usually means owning the whole supply chain, like Rockefeller owning the oil wells, the trains, and the refineries.
Exactly that. In the tech world, it means companies that used to just be in the application layer, like Google or Meta, are moving down the stack.
Okay.
They aren't just building apps anymore. They're buying the backbone. They're laying their own undersea cables. They're becoming the access providers in some places with projects like Starlink or Google Fiber.
So they own the app you use, the cloud it runs on, and the physical cable that delivers it to your house.
Precisely. And that gives them a level of power that is unprecedented. If you own the physical infrastructure, you set the rules of the road. It's not just about censorship or algorithms anymore. It's about the physics of information flow.
You can control everything.
You can prioritize your own traffic. You can squeeze out competitors at the hardware level.
And the matrix helps us compare how different governments handle this too, right?
Yes. You can compare how an authoritarian regime controls these layers versus a democracy. Maybe a regime controls the access layer, tightly shutting down the internet entirely during protests, while a democracy might focus on regulating the data layer through privacy laws like GDPR.
I see.
It moves us from just theorizing about social relations to a materialist analysis. Who owns the physical thing? Because at the end of the day, whoever owns the thing holds the power.
It all comes back to ownership of the physical. It seems like the recurring theme of this entire handbook is forget the code, follow the cable.
It is. We can get lost in the digital ether, but ultimately, someone holds the deed to the data center. Someone owns the cable landing station. And that ownership dictates our digital reality.
This has been, frankly, a little grounding, pun intended.
It is grounding. That's the whole point, to bring us back to Earth.
We started with the myth of the cloud ethereal, magic, perfect. And we've ended up with reality that is surprisingly gritty.
We've traveled from the sandy coast of Lagos, where they are literally dredging up the ocean floor to build a finance hub,
To the Himalayas, where fiber optic cables are bringing dust and smoke to indigenous mountains.
to the swamps of Louisiana, where workers are wading through muck just to keep the lights on.
And to a village in India, where a shop owner is hiking up a hill just to get a signal so his neighbors can eat.
And through it all, the core theme remains. Data is not magic. It is a material resource, and it requires immense, often invisible labor to maintain. It requires sweat. It requires vigilance.
I want to go back to that thought experiment you mentioned about the vandal in the soil archive.
Yes, the pilot dirt on the floor.
It's such a haunting image.
It is. And I want to leave the listener with a final provocative thought based on that.
Go for it.
Think about the vandal, not as a person, but as entropy, as time, as nature. If we stopped the maintenance, if the line workers stopped fixing the poles, if the cleaners stopped dusting the servers, if the telemetry team stopped watching the AI models, how long would it take
How long would it take for what?
for our digital society to turn back into just dirt? It wouldn't take long. Without the constant injection of energy and labor, the order collapses. The data becomes noise. The archive becomes a pile of soil. The internet becomes a rusted cable in a swamp. The cloud evaporates.
So the next time you see a 404 error or a spinning loading wheel,
Don't think of it as a cloud malfunction. Think of it as a brief glimpse of the chaotic reality that the infrastructure usually hides from you. That 404 error is the swamp trying to reclaim the pole. It's the dust settling on the lens. It's the vandal at the door.
that is a terrifying and beautiful place to leave it. Thank you so much for helping us unpack this massive handbook.
It was a pleasure. It's always good to get our hands dirty.
And thank you to you, the listener, for taking the deep dive with us. We'll see you next time.